Welcome to Lecture 27. You will recall uh, that we were in Lecture 26. At the end of 26, we were still in the middle of a design problem in which we were trying to design a sequential circuit to detect a certain sequence in the input. And in this case, we were assuming that we were working with T flip-flops. And so we had arrived at the excitation table shown here by the time that we finished Lecture 26. But we wanted to go all the way to the point of showing the appropriate circuit, so we still have just a little bit more work to do. We see here in this table TA, TB, and the output Z for various values of X, A, and B. So as this remark points out, in order to draw the circuit, we need to first find out how TA and TB, and for that matter Z as well, let's go ahead and say and Z, are related to A, B, and X. And we would like, since we're going to be drawing circuits for this, and we'd like to keep the circuits as simple as possible, we would like to find these minimal expressions for TA, TB, and Z as functions of X, A, and B. And so, as you might anticipate, we'll be looking at Carnot maps. So let's start, for instance, with TA. So we're going to regard each of these now as a function of X, A, and B in that order. So this is TA, TB of X, A, and B, and Z of X, A, and B. So let's start with TA. Okay, so for TA, we see that when X is equal to 0, TA is given by these numbers, and so we just, now X equals 0 is the first row of the Carnot map, so we need to fill in those numbers, but remember to fill them in the correct way. So when A and B are both 0, and X is 0, then TA is 0. So we'll get a 0 in this cell in the Carnot map. For A and B equals 0, 1, we have 1. Here's A and B are 0, 1, and TA is equal to 1. When A is 1 and B is 0, TA is 1. And note that that's over here in this cell of the Carnot map. A is 1 and B is 0. And when A and B are both 1, TA is 0. So that goes here in this cell. And now we fill in the same information for X equals 1. So when A and B are both 0, TA is 0. In fact, actually, you can see that TA has exactly the same expressions for X equals 0 and X equals 1. So the second row of the Carnot map will look just like the first row. And we can go ahead and complete it like that. And that is the Carnot map for TA. Before we analyze that, let's go ahead and put the Carnot maps, identify the Carnot maps for TB and Z as well. Okay, so now for TB, when X is equal to 0, we have this column that needs to be transferred to the Carnot map. So the first entry is 0, and the next entry when A is 0 and B is 1 will be 1. Actually the final entry over here where A is 1 and B is 0, that corresponds to this, and so that's 0. And then when A is 1 and B is 1, TB is 1. So we fill that in here. And now for the second row of the Carnot map, we look at this column. So we have 1 when A and B are both 0, 0 when A is 0 and B is 1, 1 when A is 1 and B is 0, and 0 when A and B are both 1. So this will be a Carnot map for T sub B. And then finally, we want to have the Carnot map for Z. And by looking at these two columns, well, we see this column for Z when X is equal to 0 is always 0. So that means that the top row of the Carnot map for Z will be 0. And then to fill in the second row, when A and B are both 0, Z will be equal to 1. And when A is 1 and B is 0, Z will be equal to 1. But in the 0, 1 case and in the 1, 1 case, in both of those cases, now I'm looking here at X equals 1, so I should point out here. So in the 0, 1 case and in the 1, 1 case, in both of those cases, Z is equal to 0, so that gives us these two zeros here in the Carnot map. So now that we have all of the Carnot maps drawn, the Carnot map for TA sub A, the Carnot map for T sub B, and the Carnot map for Z, we ought to be able to finish this fairly quickly. So let's make some workspace for this. We'll look for minimal sums in each case. For T sub A, we see that we have no rectangular groupings of 4 1 cells, so then we look for rectangular groupings of 2 1 cells, and we have, of course, 2 of those, this one and this one. And so this one, if we look, notice that we have A prime B, and for this one we have AB prime. Notice that each of those is essential because all of the 1 cells here are essential 1 cells, and therefore both prime implicants are essential prime implicants. So we have A prime B is essential, and so is AB prime, and therefore the minimal sums will simply be TA of X A B is equal to A prime B or AB prime. which of course can also be written as A exclusive or B. And that is the only minimal sum. Now let's look at T sub B. Again, there are no rectangular groupings of 4 one-cells, but we do have 2 rectangular groupings of 2 one-cells. We have this one, and we have this one. The top one is X prime B. And this other one will be X B prime. Again, all of the one cells in this problem are in this kernel map are essential, and therefore both of those prime implicants are essential. And therefore the minimal sums in this case, once again, there will be only one, and it is T sub B of X A B equals X prime B, or X B prime, which is X exclusive or B. And now finally for Z, once again there are no rectangular groupings of 4 one-cells. However, there is a rectangular grouping of 2 one-cells, and it is this. And that is simply XB prime. And of course, both of those one cells are essential. So XB prime is essential, and all minimal sums will simply be Z of X A B is equal to X B prime. And now that we have these expressions, we can go ahead and finish this problem in the following way. Of course, different people might draw it in slightly different ways, but the everything should be consistent with the following. And I believe that that will be it. Notice what we have here. Here are our two T flip-flops with inputs TA for the top one, TB for the second one. And notice this is exclusive OR gate, and this is an exclusive OR gate. This is an AND gate. So we see that TA is the exclusive OR of A coming in here and B coming in there. So we have TA is A exclusive OR B, which is consistent with this equation. We also have exclusive OR gate for TB, and it is the exclusive OR of X and B, which is consistent with this equation. And then finally, this X also comes down here and gets ANDed with B prime to yield Z, and that's consistent with this equation. And so that concludes the problem. Here is the sequential circuit for detecting the sequence that was specified in lecture 26. And that's now you have an example of how we can work backwards from a word description of the desired behavior of a sequential circuit. Work backwards. First do the state graph, then the state table, and then the transition table, and then the excitation table, and then finally with the excitation table we'll look at the different excitations in the output, determine how these are related to the states and the input by using Carnot maps, and finally then we'll be able to draw our sequential circuit. So that is the design procedure. It is identical to the analysis procedure, but performed in the reverse order. So that concludes that topic. And so now let's talk about some test problems here. We have just gone through this procedure for what to do with T flip-flops. Now you will recall that in lecture 26, in the test for lecture 26, you were supposed to do this, you were supposed to find the appropriate excitation table when these T flip-flops were replaced by D flip-flops. So in other words, if we come back up here to the beginning of this lecture, here's the excitation table when T flip-flops are used. Well, you should now have, as a result of the work you did for test 26, you should have this excitation table for D flip-flops. And so now your assignment for the test for this lecture is to find out how D sub A, D sub B, and Z will be related to X, A, and B when we have D flip-flops rather than T flip-flops. So we'll take a brief break and then come back and look explicitly at the questions under consideration. Okay, so now we're ready to discuss the test for lecture 27. And once again, what we're discussing here is the excitation table that you derived at the end of lecture 26. So that excitation table was, just to make sure we're all together, you'll remember that in lecture 26 we were trying to detect this sequence 0, 1, and so we, after some preliminary remarks, we came up with this state graph, and here was the state table, and here was the transition table. Now, this was the excitation table that we arrived at here if we assumed T flip-flops for A and B. However, in your test for that lecture, you were supposed to assume D flip-flops for A and B. And when you did, this is the excitation table, and you were supposed to fill in the blanks. I filled in the diagonal terms here for you, and you were supposed to fill in the rest. And that was for lecture 26. So now you should have this entire excitation table. You should have the all of these blanks filled in. You should know what everything is. So now that you have that, we come over to lecture 27, and what you're supposed to do is just as we did here in lecture 27, where we found TA and TB as functions of x, a, and b. Now you're supposed to go back to the table that you derived for lecture 26, where you were using D flip-flops and you derived all the values for dA and dB. Now you want to find correct expressions for dA as a function of x, a, and b, and dB is a function of x, a, and b. And I see I haven't filled in these values yet, so I'll fill those in and then we'll come back. But just remember now, this is for the table that you derived in lecture 26. So now we've filled in the answers. In 27.1, you're asked to find the correct expression for D sub A. Is it A, B, X, or XA plus X prime B? And you have those same choices and in the same order in 27.2, where you're supposed to find the correct expression for D sub B of X, A, and B. And remember now, D sub A is the input to the D flip-flop whose output is A, and D sub B is the input to the D flip-flop whose output is B. And so the choice A is A, the choice B in both cases is B, the choice C in both cases is X, and the choice D in both cases is XA, ORed with X prime B. And then in class, we'll have 27.3. So that concludes this lecture, and good luck.